Welcome to my new video. Now we are going to go through the NOR gate. A NOR gate is also a fundamental digital electronic gate. It is the opposite of the OR gate. It combines an OR gate with an inverter on the output, and now then you get a NOR gate. Com In the NOR gate, output goes low if one or both inputs are low. Output goes high when both inputs are low. So if we have this here on the left side is the symbol of a NOR gate. As you can see, it's also like the OR gate, but it has a bubble here on the right side on the end of this OR gate. So when the both inputs are 0, the output is 1. If only one input is 1, there will be 0 on the output, and if both inputs are 1, there is going to be a 0 on the output. So it's basically the opposite of the OR gate. So now I'm gonna run this program called Proteus. Here is the schematic of an OR gate. Here are the inputs A and B, two input NOR gate, and here is the output. Let me just run the program. Sorry, it's a little bit slow now because I just turned on my PC, and yeah, when I'm recording it isn't very great. So sorry about this. Usually it doesn't happen to me, but occasionally it does. Okay, now as you can see, the output of the NOR gate is 1 only if all the inputs or both inputs are on a low state. If just one is 0 1 and on the input, there is always going to be 0 on the output. And if I turn back the zeros here on the input, the output is going to have 1. This is my next this is the switch analogy. I'm just gonna run the currents, make the show the current. Now if these switches, when they are open, they act as 0. When the switch is closed, they act as 1, like so. Here you see. So if I close these switches, they act as 1. If I open them, they act as 0. So now they are both 0, and the lamp is going to glow pretty bright. But if I just click close one, then the current will be drawn here a lot more than here. So there is not going to be enough amount of current for this right side. There's not going to be enough amount of current, so the lamp will not glow. And also if I close, then it will be less current here. So this lamp is going to glow if all the inputs are on low state. So this is an OR gate also. This is the switch analogy, which is the oldest one in digital electronics. Now here we have a transistor analogy. Now I have input A and input B on 0 volts, and when there is 0 volts here on the A and the B, there is no current going to the bases of these two transistors, so they are not going to conduct. So therefore the voltage here in this node is going to be 0, and this current, this resistor Q3 is also closed, and here the voltage will be the power supply voltage here plus 5 volts. So when I run the program here, remember now it is a low state. It is only 0. It is 0 volts on the A and on the B. Now all the transistors are blocked, and here on the output, like so, like here, is going to have a high state, 5 volts. This is same as the OR gate, but with the NOT stage. added here. This is the not stage. Okay, now when I put just one, for example 5 volts here on the A input, on the A, then this transistor will conduct, so that the current can go from the collector to the emitter and to the resistor R2. There will be a voltage here, so that there is going to be a positive voltage, so this transistor will conduct, and therefore there will be current passing through this transistor Q3, and then the voltage here is not going to be 5 volts. So let me just run the program. As you can see, now it is 0.01 because there is a current passing through here. We have a high state, and then because it is a not stage here, then it is going to be 0 volts. If both also conduct, the situation is going to be the same, because there are two transistors. Also this base is going to conduct, and therefore the collector can go, the current from collector can go to the emitter, and there is a voltage dropout of about 0.01, but that acts as a low state. Now here on the low side, I want to show you that for a NOR gate you can have many inputs as you can have. The output is always going to be 0 if only one input is 1. If all the inputs are 0, their output is going to be 1, like so here. But if I just bring one input on a high state, the output goes 0. Also here it changes for the 5 input line. Yeah, and yeah, you just have to remember that if you only bring one input into the NOR gate, the output is 0. So that's it for this tutorial. I hope it helped you, and see you in my next video. Goodbye.